What is blood pressure? Blood pressure is that force the blood that is flowing through blood vessels exerts on the walls of the blood vessels. When blood is flowing through blood vessels, it has to go forward, but as it is going forward, some of it has a tendency of wanting to go through the walls directly, and when that happens, there is a force that it exerts on those blood vessels, and that generates what we call a blood pressure. It happens with all the fluids that flow through closed entities or tubes or pipes, that when this fluid is flowing through, it generates a pressure due to the force that it exerts on the walls of that particular vessel. And that blood pressure, or that pressure generated, is actually very important. If the pressure is not there, it means the force this blood is exerting is also not there, or it's not adequate. And if it's not adequate, even the flow of this particular fluid, in this case the blood, will not be adequate, which is problematic. And if it is so high, it also becomes a problem. Look at a pipe that has water flowing through it. If you want to know or estimate how much pressure is in this pipe, you will look at how this water is coming out of the jet. If the projectile is so distant, or if the water is coming out at a high speed, it's just splashing, you get an impression that is under pressure. And if it is just dripping, coming out slowly, then you get the impression that the pressure within the tube is low. So that is the same thing. Even within the blood vessels are like tubes, small tubes within the body that help to transfer blood into the different parts of the body. You have a pump, the heart in your chest, that keeps receiving blood and then sending it to the different parts of your body through what we've called the blood vessels. I want you to look at a garden somewhere, and then a water source, maybe a river, and then you have to ensure some of the water from the river is taken to the garden to irrigate the crops and all. And then you station a pump next to the river, you connect a tube to the pump, and then to the garden. So what this pump does is to pump the water from the river or the water source through the tube to the garden, where this water is needed to ensure the crops grow, they bear fruit, and so on. Even your body is like a garden, and there are different activities that take place in the different parts of your body. And those different activities require nutrients, require water, require energy, require different things really. And some of those things you get when you eat food, for example, and so on. But how do these things, for example, that you have eaten, end up reaching the different parts of your body? It means there should be a transportation system that conveys whatever you have eaten from your intestines to those different parts of the body where those nutrients or requirements are needed. So that transportation system is blood. What happens is when you eat, those nutrients, the food products that you've eaten, end up entering or crossing from the inside of the intestines into the surrounding blood vessels. When those nutrients enter, they now flow with the blood to where they are going to be used. But this flow has to be maintained. It's not like how water flows in a river, which is tilted, and so the water can easily flow because there is a slanting somehow for you, sometimes you're sleeping, sometimes you're walking, sometimes you're running. So it's not like blood is going to flow like it flows in a river. There is supposed to be a pump, like how we talked about the pump in the garden scenario. And this pump is the heart, which is located in the chest. It has blood vessels, all those tubes that receive the blood that is coming in from the rest of the body, and then other blood vessels that lead this blood out. So the heart will just pump for this blood which has come in to leave at a pressure. So that pressure it leaves the heart with is going to help it continue flowing to the different parts of your body, to the head, to the toes, to the hands, and every other part of your body. So the pressure with which this blood moves can be normal, it can be low, it can be high. If it is normal, well and good. There is a range. If it's normal, within the normal range, that's okay. Problems come in when it is low or when it is high, above the expected normal. And today we are going to be talking about the high one, the high blood pressure, which is very common and which is also very problematic and disastrous. So that is generally blood pressure. But this blood pressure has two components. Remember, when your heart is pumping, a time comes and it is pumping. We call that contraction. When it is contracting, it contracts to push out the blood that it had collected. And after it has finished contracting or pumping out, it has to relax to let in the blood that is now coming in from the other parts of the body. So it relaxes. When it is full, it contracts again and it pushes out the blood. Now, the blood pressure is measured in accordance to those two different phases that take place in the heart. We measure the blood pressure when your heart is contracting, and we also measure it when your heart is relaxing. That's why if you have seen a recording of the blood pressure, it has always appeared as a two-figure recording or reading, one up and one down. The one up is the one that corresponds to the time or to the pressure in the blood vessels at a time when the heart is contracting or pumping out the blood. And the one down is the one that corresponds to the time when your heart is relaxing, trying to fill up with blood. In the medical language, the upper one, we call it the systolic blood pressure, because that process when the heart is contracting and pushing out blood is called systole. And then the one down is called diastolic pressure, because the process or the time when your heart is relaxing to fill up with blood is called diastole. So those are the two different values that communicate about how your blood pressure is generally. So basically, that is blood pressure. And what does that actually mean? It means everyone has a blood pressure. For as long as you are alive and you are still living, it means you have a blood pressure. It is only dead people who don't have a blood pressure. Everyone has a blood pressure. That's important because for long, people have always said, I have pressure. I have pressure. I went to hospital and they told me I have pressure. Nina pressure. That's not right because everyone has a blood pressure. Probably you were told you have a high blood pressure or you have hypertension. But if you just simply say, I have pressure, you have not communicated a lot because literally everyone has a pressure, and blood pressure is very important. Without blood pressure, you can't survive because it means your blood will not be flowing appropriately to reach the different parts of your body. And How will you live like that? So basically speaking, that is blood pressure. Now we shall go into high blood pressure. If you have a high blood pressure, that might come as a result of many reasons. It puts you at risk of getting complications, of getting damages to your blood vessels and different parts of your body. Because I want you to look at it in a way that these tubes, the ones we are calling the blood vessels, are open and they are a certain size. When the blood pressure, the pressure with which the blood flowing through is high, it means a lot of tension is going to be put on the walls of those tubes or those blood vessels. Now, when that tension is so high, many things can happen. One, there can be damage to the walls of the blood vessels because they are being distended, and that damage can cause problems. The body is designed in such a way that whenever there is a form of stress, it will try to compensate or to put up a form of resistance so that it doesn't fail to do its work, so that you don't die. The body always works to ensure that you survive. So when your blood vessels are under a lot of tension due to a high blood pressure, they will become thick and stiff. That's a way of putting up resistance. You know, if a tube has a very narrow wall and the pressure inside increases, it means it can rupture any time. So what the body does is to make these blood vessels, which were just as thin as this, the wall becomes a bit thicker, and that kind of protects you. And also, on top of becoming thicker, they also become stiffer, so that this tension doesn't distend them or doesn't actually make them rupture or give way, so that you continue to live. But that kind of modification also comes along with its own challenges, because under normal circumstances, these blood vessels, especially we are talking about the blood vessels that carry blood away from the heart to the different parts of your body, because we have different types of blood vessels. We have those that carry blood from the heart to the different parts of your body. Those are called arteries. And then we have the blood vessels that carry blood from the different parts of the body when it has delivered whatever it had gone to deliver back to the heart, and those are called veins. Between the veins and the arteries, they are interconnecting vessels, very tiny, and they are called capillaries. When we are talking about high blood pressure or blood pressure generally, we are majorly focusing on the blood vessels that take blood from the heart to the different parts of the body, and those are the arteries, majorly. So when your arteries or these blood vessels taking blood to the different parts of the body become stiff, thick, they lose their ability to expand, and that is important. It is also protective. How? When you are under stress, when you are preparing for a strenuous activity, when you are frightened all of a sudden, when something that is meant to make you active happens to you all of a sudden, there is need for the heart to deliver a lot of blood to the different parts of the body, so that the body is prepared to do those different things. For example, if you have to run all of a sudden, it means you're going to spend energy. The process of running is an active process. It needs energy. And how does this energy come about? The energy is generated from the nutrients, from the glucose, from the sugars that you ate as food. So it means these sugars have to be delivered to the different parts of the body, be the muscles and all, so that you actually generate the energy to run or to do any other activity. Like when someone has to fight all of a sudden, those things are meant to happen. So the heart has to push blood so that it reaches faster, so that the body can generate energy from the nutrients that are coming in real quick. So when the heart pushes blood real fast at a high force, the blood vessels can still do that. They can still deliver the nutrients and the blood real quick where it's needed, when the blood pressure has not increased above normal, under normal circumstances. And how does that happen? When the blood from the heart is coming in with a lot of force, the blood vessels will expand. When they expand, they take in a lot at a time, but when the blood pressure in there has not increased markedly. But if they are not able to expand, because they are no longer elastic, they are now stiff, because for you had a high blood pressure, it means the force that this blood is coming with is going to make the blood pressure increase abnormally high. It's going to, the blood vessels now again to be under more tension, because what's the blood, if the blood vessels don't want to be under a lot of tension, they have to expand. They have to expand. But now, because they are already stiff, the blood coming in is coming in with a lot of force, running so fast, they are not able to expand. The blood pressure in there is so high, it might cause them to rupture, to burst, to give way. Now, when such a thing happens, it means the part of the body which that particular blood vessel was taking the blood for is not going to receive the blood. And when that part of the body doesn't receive the blood, it is going to start dying off, because it's not feeding, it is starving. It starts to die off, or it gets damaged. And it's that damage that makes you ill, because now you will get the symptoms and you will not be able to perform as you were. For example, if such a thing happens in the brain, those are the people who end up with what we call a stroke, where a certain blood vessel gives way and maybe blood pours, and you get blood pooling up within your head, which causes damage to the brain, and we say you have stroke. But we shall be dealing with that later on in this video. So that is one of the things that can happen. Sudden engagement in a strenuous physical activity or certain stress makes your heart push out a lot of blood at a time with a lot of force that causes a lot of tension in these different blood vessels that can rupture and cause blood cut off to that particular part of the body where the blood was heading. Or in the process of these blood vessels becoming narrow and narrow and narrow, what happens? A time comes when the blood vessels are now very narrow, that they can only deliver a little blood at a time. A blood vessel that was this wide, because of the persistent high blood pressure, it starts to narrow. It starts to narrow. it starts to narrow, and it reaches a time when the amount of blood it can deliver at a time is not enough, and this will still cause the part of the body where this particular blood vessel was taking blood to get damaged. Sometimes this narrowing goes on until when this particular blood vessel becomes blocked, and when that happens, still you will not have blood delivered to that part of the body where the blood vessel was taking the blood. When such a thing, for example, takes place in the heart, those are the people you hear got what we call heart attacks. Someone got a heart attack. Sudden blockage of blood flow to the heart that caused the muscles or the cells or the tissues that make up the heart to start dying off. And when parts of the heart start to die off, there are symptoms that you get, and that is problematic. So that is high blood pressure, and those are things it does.